Look up at the night sky and you see a flat band of light stretching across the dark. That's the Milky Way, edge on, flat. But here's the question almost nobody asks. What's above it? What's below it? Not the stars around us, not the neighboring arms of our galaxy. Straight up, straight down, off the disk entirely, into the space our galaxy doesn't officially occupy. For decades, astronomers had almost nothing to say about it. It was blank space on the map, the part of the galaxy nobody photographed because there was supposedly nothing there to see. They were wrong. Above and below the Milky Way, there are structures so large they defy comprehension. Bubbles of gas superheated to millions of degrees blasting out from the galactic center. Magnetic fields organized into filaments that stretch for distances the human mind isn't built to hold. A halo of ancient stars orbiting in the dark far outside the galaxy we think we know. And buried in the data, a glow that shouldn't exist, something that might be the first direct fingerprint of dark matter ever recorded. None of this is above and below in the way you'd picture it. This isn't a ceiling and a floor. It's a hidden architecture wrapped around every side of our galaxy that most people will go their entire lives without knowing exists. We're going to go there, straight up, straight down, past everything you can see with your own eyes, into the space that makes the Milky Way far stranger than the postcard photo suggests. Start close, relatively speaking. At the exact center of our galaxy sits a supermassive black hole, Sagittarius A star. Quiet now, most of the time, but it wasn't always quiet. In 2010, astronomers using the Fermi Gamma-ray Space Telescope found something they couldn't explain. Two enormous lobes of energy erupting from the galactic center, one punching straight up out of the disk, one punching straight down, symmetrical, massive, glowing in gamma rays, the most energetic light in the universe. They called them the Fermi bubbles. At first, nobody knew what to make of them. A local fluke, maybe, some kind of nearby stellar wreckage. Then in 2020, a different telescope found their twin. Using X-ray data, scientists mapped out a second pair of structures hidden inside the same regions of sky. They called these the eROSITA bubbles. And the scale of what they found was almost impossible to accept. These bubbles extend more than 45,000 light-years above and below the center of our galaxy, on each side. That's not a stretch of space. That's most of the width of the entire Milky Way disk projected straight up into the dark and straight down into the dark twice over. Picture it like this. If our galaxy were a dinner plate, these bubbles would be two enormous balloons, one pressed against the top of the plate, one against the bottom, each one nearly as wide as the plate itself. They're not empty. Inside them is gas and plasma heated by shock waves to temperatures that would vaporize anything solid instantly. The boundaries of these bubbles are sharp, defined, like the edge of an explosion frozen mid-blast. So what caused something this violent? There are two leading suspects. The first is our black hole, not eating quietly the way it does now, but going through a much more active phase sometime in the last several million years, blasting out jets of superheated material as it consumed gas and dust. The second suspect is star formation. Not one star, not one supernova, a firestorm of them. A ring of intense star birth sits a few thousand light years out from the galactic center. Stars are born there, live fast, and die in explosive supernovae over and over in a chain reaction that pumps out enormous amounts of energy. Multiply that across thousands of stars over millions of years, and you get outflows powerful enough to blow bubbles the size of small galaxies straight out of the disk. The honest answer is that astronomers aren't sure which one did it. Maybe both did. But here's the detail that should stop you. These bubbles are still there, still glowing, still expanding slowly into the space above and below us. Every single night when you look up at the sky and see nothing but stars, there are two invisible structures the size of galaxies sitting directly overhead and directly underfoot, left behind by an event we still can't fully explain. The bubbles were strange enough on their own. Then astronomers looked closer and found something inside them nobody expected. A magnetic field. Not a weak, scattered one, a vast, organized structure wrapped around the bubbles like scaffolding around a building under construction. Researchers combined data from more than 10 different sky surveys across radio waves, X-rays, and gamma rays to map it out in detail for the first time. What they found were long magnetic ridges threading through the halo above and below the galactic disk, not chaotic, coherent, structured, as if something had combed the space above and below our galaxy into deliberate lines. The filaments they mapped stretch across distances equal to roughly 150 times the width of the full moon in our sky. Try picturing that. Take the moon, as it looks to you tonight. Now imagine a single magnetic thread stretched across 150 moons laid side by side, glowing faintly in wavelengths your eyes were never built to see. Why does this matter? Because magnetic fields aren't decoration. They shape everything they touch. They can funnel gas, accelerate particles to near light speed, and act like invisible rails guiding matter through space. A magnetic halo this large, this organized, sitting directly above and below the Milky Way means our galaxy is doing something far more active than just sitting quietly and burning starlight. It's breathing. Material is being pushed out from the star-forming regions near the galactic center, dragged into these magnetic ridges, and carried up and out into the halo. Some of it may eventually fall back down, feeding future generations of stars. Some of it may escape the galaxy entirely, lost to intergalactic space forever. This is called a galactic outflow, and it's not unique to us. If the Milky Way behaves this way, then other spiral galaxies across the universe are likely doing the same thing, breathing out their own invisible halos above and below their disks, unseen from the outside, just as ours is unseen from within. We happen to live inside a galaxy that's still actively shaping itself, still venting energy, still, in a very real sense, alive. And almost none of it is visible to the naked eye. It took over a decade of combined data from telescopes built to see wavelengths of light our eyes can't process, just to draw the outline of what's hanging directly above and below us right now. Push out further, past the bubbles, past the magnetic filaments, into a region called the stellar halo. This is where things stop being explosive and start being ancient. The stellar halo is a sparse, roughly spherical shell of old stars that surrounds the entire Milky Way disk, extending above and below it in every direction. And when astronomers say it extends far, they mean it in a way that's hard to compress into a single sentence. This halo stretches out several 100,000 light-years above and below the plane where our sun and solar system sit. For comparison, the visible disk of the Milky Way, the flat part most people picture when they think galaxy, is roughly 100,000 light-years across. The stellar halo dwarfs it. It's not a thin cap sitting on top of the disk. It's an enormous, diffuse sphere engulfing the entire galaxy we think we know. Here's the strange part. Because we live inside the Milky Way, embedded in its disk, we've never been able to step outside and simply look at our own stellar halo the way we can with other galaxies. Astronomers can point a telescope at a distant spiral galaxy and directly image its glowing halo of stars from the outside. We can't do that with our own. We're stuck inside the fishbowl trying to map the shape of the glass by studying the fish. To solve this, scientists combined two enormous surveys. One is Gaia, a spacecraft that has spent years precisely measuring the positions, motions, and distances of over 1 billion stars in our galaxy. The other is a ground-based survey using a telescope in Arizona, capable of reaching stars too distant and too faint for Gaia to measure. Together, these two datasets let researchers finally reconstruct the shape of our stellar halo in 3 dimensions. And what they found surprised them. It isn't a perfect sphere. It's tilted, lopsided, skewed at an angle relative to the galactic disk, likely a scar left behind by an ancient collision. Sometime in the deep past, another smaller galaxy may have slammed into the Milky Way, and the wreckage of that impact is still smeared across the halo above and below us today, in the form of loose, ancient stars orbiting slowly through empty space. These aren't young stars. Many of them are some of the oldest objects in the entire galaxy, remnants from an era before the Sun existed. When you look above the plane of the Milky Way at night, a faint scattering of what you're seeing may be stars that predate our entire solar system, drifting through a region so vast it makes the visible galaxy seem small by comparison. And this halo isn't just a graveyard of old stars, it's a map of every galaxy the Milky Way has ever consumed. Everything so far has been detectable: gas, plasma, magnetic fields, ancient stars. All of it eventually leaves some kind of trace that a telescope can pick up. Now we get to the part that doesn't. Surrounding the stellar halo, extending even further above and below the galaxy than the ancient stars themselves, is something called the dark matter halo. Nobody has ever seen it directly. Nobody ever will. Not with a telescope, not with any instrument that detects light. Dark matter doesn't emit light, doesn't reflect it, doesn't block it. It is, as far as every experiment to date can tell, completely invisible. And yet, astronomers are confident it's there, wrapped around the Milky Way in a sphere so large it makes even the stellar halo look small. Here's how they know. Stars near the outer edge of our galaxy are orbiting far too fast. Based on the visible mass of the Milky Way alone, the gravity of the stars and gas we can see shouldn't be strong enough to hold those outer stars in orbit. They should be flying off into intergalactic space. They're not. Something with enormous mass but no visible presence is holding them in place. That something is dark matter, and based on the math, it doesn't just sit in the disk with the visible stars. It extends outward and upward, above and below the galaxy, in a vast, invisible halo that outweighs everything we can actually see combined. Think about what that means. Every star you've ever looked at, every nebula, every visible structure in this entire galaxy might make up less than a fifth of the Milky Way's total mass. The rest, the majority of our galaxy, is sitting directly above and below you right now, completely undetectable, silently keeping the entire structure from flying apart. This is one of the strangest facts in modern astronomy. We can calculate its presence with extraordinary precision. We can map its approximate shape by watching how it bends light from galaxies behind it, and by tracking the motion of stars trapped in its gravity. But we cannot see it, touch it, or directly detect a single particle of it, despite decades of dedicated experiments built specifically to try. The dark matter halo is the true edge of our galaxy, not the last visible star, not the stellar halo. This invisible sphere, stretching hundreds of thousands of light years above and below the plane, several times wider than everything we can actually observe combined. And for a long time, that's where the story ended, an invisible boundary, detectable only through gravity, with no direct evidence it exists at all. Until recently. This is the part of the story astronomers are still arguing about. A researcher analyzing 15 years of data from the Fermi Gamma-ray Space Telescope set out to do something painstaking. Look at the region above and below the Milky Way's disk, the galactic halo, and carefully subtract every known source of gamma-ray light, interstellar gas, cosmic rays, the Fermi bubbles themselves. Subtract all of it, piece by piece, and see what's left. What was left shouldn't have been there at all. A faint, extended glow of high-energy gamma rays spreading out above and below the galactic center with no known source to explain it. Not gas, not known cosmic ray interactions, not the bubbles, something else. The energy detected sat around 20 billion electron volts, an extraordinary amount of energy for a single photon, arranged in a halo-like structure wrapping toward the center of our galaxy. And here's where it gets genuinely explosive in the scientific sense. One of the leading candidate explanations for this leftover glow is dark matter itself. The theory goes like this. In some models, dark matter particles can occasionally collide and annihilate each other, releasing a burst of gamma-ray energy in the process. If the dark matter halo really does surround the Milky Way the way the math predicts, then regions with extremely dense concentrations of dark matter should produce faint but detectable gamma-ray signals, exactly like the one found in this leftover glow. This would be enormous. For the first time in history, it would mean scientists weren't just detecting dark matter's gravity, they'd be detecting light created by dark matter itself, direct evidence rather than an indirect inference. To be clear, this isn't confirmed. Scientists are cautious, and they should be. There are other possible explanations still on the table, including sources of gamma rays we simply haven't identified yet, hiding in the halo above and below us. Almost a century after dark matter was first theorized, after decades of experiments finding nothing but gravitational fingerprints, this may be the closest anyone has ever come to catching it in the act. Somewhere above and below the Milky Way, in a region most people will never think about, there may be a very faint, very real light being emitted by the very thing that holds our entire galaxy together. So go back to the question we started with. What's above and below the Milky Way? Not empty space, not a blank ceiling and floor around a flat disk of stars. Directly above you tonight and directly below you tonight, there are bubbles of superheated gas larger than most galaxies, left behind by an eruption from our own black hole or a chain reaction of exploding stars, still glowing, still expanding, tens of thousands of light years into the dark. Wrapped around those bubbles, a magnetic halo, threading gas and energy out of the galactic disk in outflows that may be common to every spiral galaxy in the universe. Beyond that, a spear of ancient stars, hundreds of thousands of light years across, tilted and scarred by a collision from deep in our galaxy's past, older than our own sun. And past even that, an invisible halo of dark matter, making up most of the Milky Way's total mass, detectable only by its gravity, and possibly, just possibly, now showing the first hints of a light we can actually see. We spend so much time looking outward at other galaxies, other stars, other solar systems, wondering what's out there. But some of the strangest, largest, least understood structures in the observable universe aren't out there at all. They're right here, wrapped around the galaxy you were born into, extending above your head and beneath your feet, right now, whether the sky above you tonight is clear or clouded over. The Milky Way isn't just the disk we can see, it's a small, thin slice of something far larger, far stranger, and far less understood, stretching out into the dark, above and below, in every direction. And we're only just beginning to map it.